we've had class, and I want to make sure everybody is on the same page. So flip to your packets on page 27. We have learned two fundamental theorems of calculus so far. The first fundamental theorem of calculus, or FTC plus 1, tells us that if I have a continuous function, then my derivative and my integral cancel each other out. In other words, the derivative of my integral is just my original function, and the integral of the derivative of my function is also just my original function. If you have a notebook, I'd highly recommend writing this down so that you have these notes. FTC Part 1 and Part 2 are super important. So my notes might start with a unit or a section header. This is Unit 6.8. It's Basic Antiderivatives. I know in your packets it's Lesson 6, but we're just going to follow the unit symbols given by AP Calculus since we're using AP Classroom for our homework. All right, so quick review. Fundamental theorem of calculus tells us, in my words, you could write them in your words, that the derivative of an integral is the original function, and vice versa. In other words, the first FTC tells us that if I take the integral of f prime of x, so I'm taking the integral of a derivative, I get back my original function. And if I take the derivative of an integral of my function, I also get back my original function. The derivative and the integrals are inverses of each other. They essentially cancel each other out. Now, we learned how to take integrals or antiderivatives. The first thing that we learned was how to take a definite integral. So when we take a definite integral using antiderivatives, I don't have a boundary. I'm just taking the integral of my derivative, and that's just equal to my antiderivative plus that constant of integration, that plus c. We can never forget our plus c's when we take indefinite integrals. But what we learned last week was how we take definite integrals when we have boundaries. So this is in your packets at the bottom of page 27, FTC Part 2. If I have a function on a closed interval from a to b, then the integral from a to b of my function is the antiderivative at the boundaries, the difference of the antiderivatives at the boundaries. So you might write this in your notes, that FTC Part 2 says that we evaluate definite integrals by taking the antiderivative. So I might take the antiderivative of f prime of x, which is just f of x, and I evaluate it at the boundaries and take that difference. So f of b minus f of a. Okay? Alright, so now that we have FTC Part 1 and FTC Part 2 reviewed, let's practice taking two indefinite integrals before we move on. So on page 28, that was the last homework assignment I gave you guys before we left for break, questions E and F. These were a little bit tricky and I saw some of you guys struggled with them, so we're just going to go over them together. All right, I'm going to do them on this blank page since I tend to write really big on my iPad. You guys can do them in your packets or you could do this in a separate notebook. Note that our packet, like we're almost done with the packet, we only have a few pages left, so you will need a notebook for the rest of this remote learning time. So you might as well start it now, get some notes. Okay, question E, let's do E first. I'm taking the antiderivative or the integral from 1 to 8 of the square root of 2 over x dx. Okay, before I take an antiderivative, just like before I take a derivative, I have to make sure that I don't have any radicals. My variable essentially needs to have a rational exponent before I can move on. So I'm going to change this into the integral 1 through 8. This is the same thing as 2 divided by x to the 1/2 power. Remember that square root is just the 1/2 power because it's power 1 root 2. Okay, and since my x is on the bottom in the denominator, I'm going to bring it up by making the exponent negative. So this becomes the integral 1 through 8 of, sorry, I think I hit something. Okay, this becomes the integral 1 through 8 of 2 to the 1/2 power times x to the negative 1/2 power dx. Okay? All right, now I can take the antiderivative. This becomes my coefficient, which is 2 to the 1/2. Leave that, that's not important. X Remember when we take antiderivatives, we do the opposite of a derivative. So I'm going to add 1 to my exponent. Negative 1/2 plus 1 is positive 1/2. Then divide by that new exponent. Evaluated from 1 through 8. And when I say evaluated from 1 through 8, that means I'm going to take 8 and plug it in for x. Then minus 1 plugged in for x. Okay, and that's it. There's no need to simplify. Once you get to that point, you can box it and you are done. If you wanted to simplify, that would be the square root of 4. It would be 4 times divided by 1/2. What is that? So that's 8 over here. Minus, this is the square root 2 square root 2. I think if you wanted to simplify that through. Is that right? Okay. All right, so that was E. Next, let's do F together. So I'm going to flip back to this page so you guys can see what F looks like. It is the integral from 1 through 4, x minus 2 on the top, divided by square root x on the bottom. All right, so this takes into account a lot of the different things that we've learned. Let me erase here so that we have more space. And I'm going to take the integral of this, but before I take my antiderivative, remember I have to flip that radical on the bottom into a rational exponent. So this is from 1 through 4 of x minus 2 divided by square root x dx, which is the same thing as 1 through 4 of x minus 2 over x to the 1/2 dx. Okay, I have two options here. I can multiply an x to the negative 1/2 through, like a distribution, or I can just split this up into two separate fractions. This is 1 through 4, x divided by x to the 1/2 dx minus integral 1 through 4, 2 divided by x to the 1/2 dx. Okay? All right, so I can simplify this. That's the integral 1 through 4 of x to the first power divided by x to the 1/2 power is x to the 1/2 power, 1 minus 1/2, dx minus the integral 1 through 4 of 2x to the negative 1/2 power, dx. Okay, again, we can take these antiderivatives now since we have rational exponents, no radicals, and nothing in the denominator. So this becomes, take my antiderivative of x to the 1/2, x to the 3 over 2 divided by 3 over 2, 1/2 plus 1, evaluated from 4 to 1, minus, and then take my antiderivative here, 2, my coefficient stays the same, x to the 1/2, since negative 1/2 plus 1 is positive 1/2, divided by 1/2, evaluated again from 4 to 1. And then when we say evaluated, that just means you're going to plug in that 4, plug in that 1, take the difference, minus plugging in the 4, plugging the 1, taking the difference. All right, so go ahead and finish solving that out, submit your answer, and then we're going to move on. Okay, flip to page 32. We'll come back to these applications in a little bit. Page 32, we're going to practice integrating a piecewise function. I'm going to introduce how you do this on your graphing calculators, and then we'll do applications of vocabulary. Okay, so I have a piecewise function. This means that I have one function, but it comes in two pieces. My first piece is this parabola, or 3x squared for all x values less than 1. And then my second piece is, let's do this in orange, the straight line, 5 for all x values greater than 1. And I want to evaluate this on each of the following intervals. When we evaluate piecewise functions, it's just important to see what intervals that we're being asked to evaluate the function on. So my first interval is from 3 to 8. So 3 to 8 means that I am strictly in this second piece because my x values are all greater than 1. I'm like from here onwards. Okay? So that means that I am evaluating this function at 5. My function is just equal to 5 since my x values are greater than 1. And the antiderivative of a constant is just add on an x, plug in the 8, plug in the 3. Okay? So that means that I have 5 times 8 minus 5 times 3, which is equal to 40 minus 15, which is equal to 25. All right. Now this next part is a little tiny bit trickier. So this question asks us to evaluate from -2 to +4. So that means that I have both pieces of the function. I'm doing this little bit right here underneath my parabola, and I'm also doing all of this here underneath the line. I can split my integral up into 2 parts and just sum those areas together. So this is equal to the integral from -2 to 1, that boundary, of 3x squared dx, plus the integral from 1 to 4 of 5 dx. Right? So I'm essentially just splitting this piecewise function up into the 2 pieces, the one that's less than 1 and the one that's greater than. The one where x values are less than 1, the one where x values are greater than 1. All right, so this becomes antiderivative 3x cubed divided by 3 evaluated from 1 to -2 plus antiderivative 5x, we did that over here, or antiderivative 5 is just 5x, evaluated from 4 to 1. All right, so finish evaluating, plug in those numbers, check your answers on Edpuzzle. Next, let's figure out how to do this in our calculators. I showed you guys really quick in class. Now, if you don't have a graphing calculator at home, there are graphing calculator apps. You can also just Google graphing calculator on Google. There should be something for you. But if I were to put this into my calculator, you're going to go to Math. And then instead of inderiv, I think it's F in int. Now we just have to be careful. Here they give us the variable in terms of x. Sometimes they give us a variable in terms of t or y or whatever. Just always put in x. We're always going to be doing my integral. This shows up on your calculator screen. Given your boundaries, whatever it might be, in this case it's 0 and 1, of my function cosine x squared divided by e to the x. So put that in. And then don't forget, this is always in terms of x. Keep it in terms of x, regardless of what the actual variable is that they give you. Okay, now this is an application of FTC2. The integral of my function is equal to my function at 1 minus my function at 0, right? And they gave us that value at 1, so this is equal to 1 over 3. And we are looking for whatever it is at 0. So you would plug this part into your calculator, find that number, whatever it happens to be, and then solve for f of 0, since that's what they're asking for. All right, finish number 8, try number 9, plug them into Edpuzzle, and then come back for one more short lesson on applications of integration. Okay, so we're going to go backwards now to page 29. Let's fill in some vocabulary. Now, integration tells us about total change, or the area under the curve. Derivatives told us about rates of change. Integration is the opposite. It's the total amount of change that has happened. So, for example, if f of t represents the rate at which my 401k, my retirement fund, changes in value over the month of January, then the units of my function are probably going to be dollars per day. So it's how much my investment changes per day. The units of my dt, or my variable of integration, is day. So you can think of that dt as the per part of my integral. F of t dt therefore means total dollars, because it's dollars per day times day, or total dollars. Therefore, the integral from 1 to 31 of f of t dt is the total change in dollars from Jan 31, or Jan 1st to Jan 31. All right, straightforward enough? So remember that integrals mean total change. So if they're ever asking for what is the total, you're looking for an integral. If they ask for what is the rate, you're looking for a derivative. Okay, try the rest of this page. Your homework is on AP Classroom. If you have any questions whatsoever, I will be online from 11:15 to 12 p.m. to answer questions.